Hello my dear students, today I will be discussing about bearing capacity of soil. The subject or concept of bearing capacity is the most important of all the aspects of geotechnical engineering. Loads from buildings are transmitted to the foundation by columns, by load bearing walls or by such other load bearing components of the structures. Sometimes what happens, the material on which the foundation rests is ledge, very hard soil or bedrock, which is known to be much stronger than is necessary to transmit the loads from the structure. Such a ledge or rock or other stiff material may not be available at reasonable depth, and it becomes invariably necessary to allow the structure to bear directly on the soil, which will furnish a satisfactory foundation if the bearing members are properly designed. It is therefore the subject of bearing capacity assumes significance. In geotechnical engineering, bearing capacity is the capacity of soil to support the loads applied to the ground. The bearing capacity of soil is the maximum average contact pressure between the foundation and the soil, which should not produce shear failure in the soil. It is the power of foundation soil to hold the forces from the superstructure without undergoing shear failure or excessive settlement. Soils behave in a complex manner when loaded. So, it is important to know the bearing capacity of soils. You can see here, this is the superstructure, ground level, and this is the foundation level. Okay, so this is the foundation and foundation soil. And here, there is a load from the superstructure because of overburden and self-weight. So, the soil exerts the pressure in the upward direction opposite to the overburden and self-weight. When the soil should have the capacity to bear this load, then only we can say that the soil has sufficient bearing capacity. The stability of foundation depends on the two main factors. The first one is the bearing capacity of the soil beneath the foundation. Second one is the settlement of the soil beneath the foundation. So bearing capacity and settlement, these are the very important concepts in geotechnical engineering. Therefore, two independent stability conditions to be fulfilled while designing any type of the structure. The first one is shearing resistance of the soil, which provides the bearing capacity. So the proper study should be undertaken while doing any the design, and also the consolidation properties that is to be carried out to know the settlement. Okay, so shearing resistance that can be that indicates the bearing capacity, and consolidation properties that determines the settlement. So these two are the important factors in civil engineering. Okay, before studying the bearing capacity in detail, we should know some of the terminologies which are related to bearing capacity. Let us see what is this foundation. The foundation, all of you know that it is the lowest part of a structure which is in direct contact with the soil and transmits loads to it. Okay, it is the lowest part of the structure which is in direct contact with the soil and transmits the load to the soil. Foundation soil or bed, that is nothing but the soil to which the loads are transmitted from the base of the structure. It is the soil to which the loads are transmitted from the base of the structure. Then footing. It is a portion of the foundation of a structure that transmits loads directly to the soil. Okay, it is the portion of the foundation only which transmits loads directly to the soil. It is a foundation consisting of a small slab for transmitting the structural load to the underlying soil. Footings can be individual slabs supporting single columns, or combined to support two or more columns, or it may be a long strip of concrete slab. Bearing capacity, the load carrying capacity of foundation soil or rock, which enables it to bear and transmit loads from a structure. It is nothing but the supporting power of a soil or rock. Ultimate bearing capacity, it is represented by QF. It is the maximum pressure that a foundation soil can withstand without undergoing shear failure. Okay, it is the capacity of the foundation soil to withstand without undergoing any shear failure. Okay, net ultimate bearing capacity QNF. It is the maximum extra pressure in addition to the initial overburden pressure. Okay, here it is the means when the extra pressure is applied on the soil other than the overburden pressure, the foundation soil can withstand without undergoing any shear failure. That is the net ultimate bearing capacity. It is given by QF minus Q naught, where Q naught represents the overburden pressure at foundation level and is equal to gamma D. Okay, for level ground without surcharge, where gamma is the unit weight of the soil and D is depth to foundation bottom from the ground level. Okay, so this is Q naught. QF is nothing but ultimate bearing capacity. Then we'll see what is safe bearing capacity, QS. It is the safe extra load the foundation soil is subjected in addition to initial overburden pressure. It is the extra safe load, okay, other than the initial overburden pressure. This is given by QNF divided by F plus Q naught, where F is the factor of safety. Okay, safe bearing capacity, that is the safe extra load. Safe, when it comes safe, there will be a factor of safety. So this is given by this equation. Then allowable bearing pressure or capacity, that is QA. It is the maximum pressure the foundation soil is subjected to, considering both shear failure and settlement. Okay, here it is the capacity of the soil to withstand both shear failure as well as the settlement, that is the allowable bearing capacity of QA. So these are some of the important terms you should know while studying in detail about bearing capacity, and also these are important while solving the numericals. Okay, now let us see what are the different types of modes of shear failure. Okay, so depending on the stiffness of foundation soil and depth of foundation, the following are the modes of shear failure experienced by the foundation soil. Here, there are mainly three types of failures. The first one is general shear failure, second one is local shear failure, and third one is punching shear failure. In the case of general shear failure, continuous failure surfaces develop between the edges of the footing and the ground surface. You can see here, this is the general shear failure, this is the local shear failure, this is the punching shear failure. Okay, and this is the graph. This is pressure and settlement, P delta graph. It is the P delta curve in the different foundation soil. This is for general shear failure A, and this is for local shear failure, and this is for punching shear failure. Now we will see in detail what is general shear failure. Okay, here in this case, when the pressure approaches the value of QF, the state of plastic equilibrium is reached initially in the soil around the edges of the footing, and it then gradually spreads downwards and outwards. Ultimately, the state of plastic equilibrium is fully developed throughout the soil above the failure surfaces. The failure is accompanied by the appearance of failure surfaces and by considering bulging of the sheared mass of soil. However, in this case, the final slip moment would occur only on one side, accompanied by tilting of the footing. Such a failure occurs in soils of low compressibility, that is dense or stiff soil, and the pressure settlement curve is of general form is as shown in the figure like this. So this is about the general shear failure. These are the some of the characteristics of general shear failure, that is continuous, well-defined and distinct failure surface develops between the edge of the footing and ground surface. Dense or stiff soil that undergoes low compressibility experiences this failure. Continuous bulging of shear mass adjacent to footing is visible. Failure is accompanied by tilting of footing. Failure is sudden and catastrophic with a pronounced peak in P-delta curve. The length of the disturbance beyond the edge of the footing is large. State of plastic equilibrium is reached initially at the footing edge and spreads gradually downwards and outwards. General shear failure is accompanied by low strain, that is less than 5% in the soil with considerable phi, that is greater than 36 degree, and large N value, that is greater than 30, having high relative density, that is ID is greater than 70%. Okay, so this is about the general shear failure. Next, let us discuss about local shear failure. In local shear failure, there is significant compression of the soil under the footing and only partial development of state of plastic equilibrium. Due to this reason, the failure surfaces do not reach the ground surface and only slight heaving occurs. Okay, you can see here it doesn't reach the ground surface, only the slight heaving you can see. The pressure settlement curve is represented by this, like this, by the curve, where the peak of the base resistance may never be reached. In such a failure, tilting of foundation is not expected. Local shear failure is associated with soils of high compressibility and in sands having relative density lying between 35 and 70%. The failure is not sudden here and it is characterized by occurrence of relatively large settlements which would not be acceptable in practice. Also, ultimate bearing capacity in such a failure is not well defined. Here, these are some of the characteristics of local shear failure, that is a significant compression of soil below the footing and partial development of plastic equilibrium is observed. Failure is not sudden and there is no tilting of footing. Failure surface does not reach the ground surface and slight bulging of the soil around the footing is observed. Failure surface is not well defined. Failure is characterized by considerable settlement. Well defined peak is absent in P-delta curve. Local shear failure is accompanied by large strain, that is greater than 10 to 20%, and in a soil with considerably low phi, that is phi is less than 28 degree, and low N value less than 5, having low relative density, ID is greater than 20%. The last one is the punching shear failure. Punching shear failure occurs where there is relatively high compression of soil under the footing, accompanied by shearing in the vertical direction around the edges of the footing. Punching shear may occur in relatively loose sand with a relative density less than 35%. Punching shear failure may also occur in a soil of low compressibility if the foundation is located at considerable depth. The failure surface, which is vertical or slightly inclined and follows the perimeter of the base, never reaches the ground surface. There is no heaving of the ground surface away from the edges and no tilting of the footing. Relatively large settlements occur in this mode. The ultimate bearing capacity is not well defined. So these are some of the characteristics of the punching shear failure. This type of failure occurs in a soil of very high compressibility. Failure pattern is not observed. Bulging of soil around the footing is absent. Failure is characterized by very large settlement. Continuous settlement with no increase in P is observed in P-delta curve. These are the three main types of shear failure: general shear failure, local shear failure, and punching shear failure. Okay, you have to go through properly, then only you will understand. I hope all of you understood. Thank you.